Well, we're going to continue talking about probability here. And we're going to look at particularly some ideas of classical probability, and we're going to find ways to make probability. So we're going to introduce some odd notation. Let me get my pen here. And so the notation we're going to write is we're going to talk about conditional probability. So some condition we're going to imply happening. And conditional probability really talks about knowledge. We have the knowledge of something happening. And so we'll say the probability of an event, and I'll probably just do probability of an event occurring given another event It doesn't want to undo that. No, we'll just say given another event. Sorry, I got that weird line. Given another event has already occurred. So I'll pause after that strange line popped out there. I don't know how I got it. Has already occurred. So the conditional probability is the probability of an event occurring given another event has already occurred. So if we have two events that happen in order, event A followed by event B, I would say the probability of event B given A has happened. And so we read this pipe as given. So the probability of B given A. And so this is a way of expressing knowledge in the system. We have some knowledge. So for example, I'm going to go back to playing cards. You'll probably see the playing cards come up a lot. I can talk about probability of events. And so we'll say, what's the probability of drawing a king on my second draw given that my first draw was a queen? And so I'm using this notation. I'm saying, the event that's happening here is queen on the first draw. And king on the second draw. And so conditional probability, well, let's see. So the probability, there are 52 cards, and there are 4 queens and 4 kings. So when I draw the first card, there's only 51 cards left in the deck. And the assumption with cards is that you don't put the cards back in the deck. Some of these questions will say that the card is not replaced. And so when I make my first draw, the probability of getting a queen on the first is 4 in 52. Right. There's a 4 in 52 chance that I can get a queen. But that doesn't really matter. I have this information now. And what has changed? Well, the probability of getting a king, given that I have a queen, I have 1 less card in the deck. So I still have 4 kings, but now I'm only drawing from 51. And so the conditional probability has me check my sample space, has me check my outcomes, and to make sure that they haven't updated. It's not a mathematical function telling me to add, subtract, or to do anything. It's saying this is going to happen. What are my chances knowing this has already happened? And so this conveys some level of knowledge. Right? What's the chance of this event given a prior event? Well, let's look at a slight variation of this. What is my probability of drawing a king on the second draw given I've drawn a king on the first draw? And so king on a first draw has 4 in 52 chance. But now I have 1 less king and 1 less card. And so that's 3 in 51. Because in this conditional probability, I have 1 less king to pull from because I've already grabbed one. And I guess if we look at our calculations here and we look at these numbers in a little detail, let's see, 4 in 51. This here is approximately 0.078 or 7.8%. And this one, the 3 in 51, is 0.059 or 5.9%. So notice these two conditional probabilities are slightly different. Why? Because in the first one, only our sample space changes. Right? The drawing of one card changes the sample space, but we still have possibility of getting 4 kings. In the second one, the sample space has changed, and I don't have one of the possible outcomes anymore in the kings because it's been removed coming across. And so conditional probability is a way of acknowledging the change that a given event does to our sample space. You can think about it as this second event is now in a different sample space because the first event changed the sample space completely. And that's the condition. All right, so we can look at this in some different ways. There's a nice table in the book where it's asking, have you ever been offended by something on social media? And the questions could be answered yes or no. And the respondents could be female or male. And so we count up everything on our table here of all of our respondents. And so we gave a survey, were you offended by something in social media? And notice there's 2 variable types coming across. The answer to the question and some demographic information. Are you female or male? And so we kind of have 2 variables coming across here. And so we're going to put some column information together. I'm going to just seal this off in a column. And so I can add up all the female respondents, and there was 1,168 of them. I can add up all the male respondents, and there was 1,008. All the yeses add up to 1,151, and all the no's add up to 1,125. Now, if I add this column together, I get 2,276. And if I add this column together, I also get that. And so the number of people we asked, or what our sample size was 2,276. And so what we want to be able to do is we can ask some conditional probabilities of it. And we can ask some different questions out of it. So what we want to do is we want to look at, let's say, the probability of picking a male respondent given they said yes. Now notice what I'm asking. I'm asking, what is the probability of a male respondent given that they said yes? So the first thing to happen, the first event, is they said yes. And so we're only choosing from this column. We start by choosing yes. So that's given now. We only have the yes choices. Well, how many men are there? There's 532 out of a possible 1,151. Grab my calculator here. We're looking at about 46%. Well, notice we can ask a slightly different question. We can say, what's the probability that they said yes, given that they were male? And so given that they were male, I only have 1,108 people in the new sample space. And the number that said yes in that sample space would be 532 also. And I think if I divide 532 by 1,000, I'm at like 49%ish. Let's see here. 48. 0.48%. So notice how these are 2 different questions. And so I can look at my data and choosing sample spaces ask different questions. And this has meaning for what we ask of our statistics. It also has meaning that if I were going out and trying to choose male respondents from the yes, I would have a different percentage of it. And so how we ask these questions from the data give us different probabilities that could come out of them. Now, this is the definition of conditional probability. I'm going to upload this video, and then we're going to look at how events, the first event and the second event, are dependent or independent of each other. We're going to look at how they're related and how they might change the outcomes or the sample space.